Hey everybody, today I'm going to show you guys how to do a chi-squared goodness of fit test. A chi-squared goodness of fit test basically helps us make the determination, is the model that we're using to describe our data appropriate when we take into consideration the things that we observe versus the things that we would expect to observe. So let's say that we go to a picnic, and at this picnic, there are 200 people. And we notice that some people are ordering hamburgers and some people are ordering pizza. Well, we want to determine, do people prefer pizza or do people prefer hamburgers, or is there really no preference at all? So this is basically this is a very simple example of how we could use chi-squared to make this determination using statistical significance. So at its core, the chi-squared goodness of fit test is basically just a frequency table where you place into it discrete mutually exclusive categories. So in this case, because we have 200 people and we observed 83 of them ordering pizza and 117 ordering hamburgers, we just put that into our observations. Then we put in our expected values. And in this case, if we would expect everybody to order pizza or hamburgers randomly, then we would expect that half the people would order pizza and half the people would order hamburgers, which would give us 100 in each category. So our hypothesis testing is a very important step. Our null hypothesis is that there's no preference for one food versus the other, or in other words, that it's just random. Or our alternative hypothesis is that there's a preference for pizza or hamburgers. So unfortunately, because this is statistics, you have to do a little bit of math, but that's okay. It makes sense. What we're basically calculating here is how much the observations that we see diverge from our expectations. So the way that we can calculate this is just by subtracting the expectations versus the observations, squaring that, and then putting the expectations in the denominator. So because we saw 83 people order pizza, we put that here in the first equation, subtract 100, which would be the expected, squared, and then put 100 in the denominator, which is also the expected. Then we do the same thing for the hamburgers category, 117 minus 100, square it, and then put the expectations in the denominator. We add them up, and we get a number. And this number is our chi-squared test statistic. And by itself, it does not really mean anything. So we have to go to a table, and these tables are pre-calculated. We have to first actually also determine how many degrees of freedom we have. In this case, we have 1 degree of freedom, and that's because the degrees of freedom is the number of categories minus 1. So we've got 1 degree of freedom because that's hamburgers and pizza, that's 2, minus 1 is 1. We got our chi-squared test statistic, which is 5.78. We move along the degrees of freedom equals 1 to where we're actually greater than the number in that row. So since we got 5.78, it's actually greater than 5.024, but less than 6.635, which means that our p-value is somewhere between 0.025 and 0.01. A lot of people we just say that our p-value is less than 0.025, which is pretty good, at least at an arbitrary level. We're like 97.5% sure that people actually prefer hamburgers to pizza. And of course people prefer hamburgers to pizza because look how freaking delicious that looks. It makes total sense. Okay, another way that we can sort of intuitively tell that there's some sort of statistically significant phenomenon going on here is we can sort of invert the matrix. And just follow me briefly. So on the left here, we see that basically how I've described this scenario. We got the observations on the left, and on the right part of this left bit, we see that there's like a 50-50. We can see that the hamburger bar in light gray is actually higher than the pizza bar in dark gray. That makes sense, that's what we've seen. But a trick to determine if there's something statistically significant going on is we can sort of like invert the matrix, which means that we group things by the opposite value. So here, if we group the observations and the expectations by pizza, and then group the observations and expectations by hamburgers, we can see that the black bars actually go in opposite directions. And this is like a very good cue that something statistically significant is happening here. When the bars actually move in different directions, that's a great like shortcut. And this is something that you will probably run into when you're doing some more advanced data analysis. And feel free to visit me during my office hours and I can help you guys out. All right, guys, have a good evening. See you guys later.